Well, good morning, everyone. See, we have a good sized group this morning. Let's see, I don't see, Lucian, are you there? Okay, just for my reassurance, could someone either go off of video mute or say they can hear me? Hands up.
Yeah, I can hear you loud and clear.
Okay, great. Excellent. Thank you very much. All right. We're going to try an experiment today. This is a new feature of the Network Modeling Summer School. We're going to try a kind of hackathon, and it's a bit challenging because usually, oh, hey, good morning, Lucian. Great. Glad to see you here. Okay. It's a little challenging because the hackathons I've had exposure to have always been in person. And so we wanted to see if we could do this at scale. And obviously, there's a huge advantage to being able to do this over Zoom in terms of making it widely accessible and really allowing participants to be anywhere on the planet. With the exception of the challenges with time zones. So the SEIR lab has started a new initiative on credibility of biomedical models. And we have some initial ideas, but we really wanted to explore this space and get a broader sense of what our criteria we should be considering with credibility, and also what it means in terms of tooling and best practices. And that's really what this hackathon is about. So let me go through. I have some startup slides to sort of get us started. The way we'll run this is Lucian and I will have separate breakout sessions, and you'll also have the opportunity to work on your own or collaborate with colleagues. We can use the chat. I think also everybody has access to the Slack channel for the summer school, I believe. And so that's another way to communicate and share, because you'll be going through and doing some analysis, and you'll probably want to see if others are coming into similar problems or have questions. So you have a few vehicles for collaboration, but obviously not quite the same thing as being in person. Okay, so I've got several sections here. We'll go through, give you a sense about where we're going. Now, this is sort of what I've given you already. The idea of what does it mean to have a credible biomedical model, and then the tooling part. And what we're going to do out of this, and it'll become more apparent what, this is a somewhat structured thing because we have, a good sized group here, is we're going to have a summary that's going to come out of this about analyses of several models. Okay, so this is really broad, credibility of biomedical models. And so we wanted to start from a common reference point. And all of us have been living on this planet for the last several years, have had to go through COVID and the challenges associated with that, and also the experience of the widespread use of models for COVID. And this context helps a lot, as opposed from starting from the point of view of some arbitrary, let's say, chemical pathway model, or some other model maybe of cell populations, because we sort of all have the same context about what these models were about. They're about helping with public health, with interventions of various sorts, understand the disease better. So we have some sense about what these models are about. That context is really helpful to talk about the credibility of the model, because credibility is always within the context. So we're going to focus, and I'll give you more definition about what these things are. I don't know how many people here just raise your hands quickly. How many people have already had some exposure to compartment models and epidemiology? I know Lucian gave a lecture that the zombie model is related to this. If you raise your hand, if you've already had some exposure, just so I get a feeling. And it takes me a while to find the buttons. Okay. Yeah. Oh, I see a few hands. Okay, there we go. Now I'm seeing hands. All right, I'd say, yeah, at least, several people have. That's great. So it turns out that these compartment models, they're fairly easy to understand, which I think is a huge advantage in many ways, both for this kind of event and also for use for the public. They also can be adapted to investigate interventions like isolation and sequestering, uh, testing for the disease. So there's a variety of things that you can do with these models, which makes sense in a public health context. It turns out also that there are about 20 papers that have been published that have SBML models in biomodels on COVID, and they're compartment models. So that also gives us a great starting point for then sort of having a level ground for comparing credibility. And we developed a framework for looking at models that we want to evaluate in the context of several published models. We chose 10 of them that they had been investigated through a tool called, well, they've been analyzed, the models themselves, through a tool called Biosimulator, and it published results on biosimulations. So we know that these models can run with several different simulators. And so that's also helpful. So again, we have a common point of reference. So that's the context in which we're going to do this, because otherwise it's a very open thing and it's not clear what we have context for. So here's how we're going to try and structure things. So that this first section here is the introduction. The next section, which I'll be talking as well, I'm going to talk about the COVID models and that we're going to be looking at, and that what resources you have available to you for the hackathon. Really, the resources are largely tools or information that through the course of this week, the Network Modeling Summer School, you've already had exposure to. So to some extent, you're applying these. And I'll tell you, the way we structured this and what this credibility analyzer is, which I'll get to in just a second, it's really sort of a checklist. And so you can read the papers, and that's actually a lot of what I've been doing. I'll show you the sort of the process I've gone through. And use that as a basis for going through the credibility analyzer, or you can also use tools, any of the tools that we've developed presented this week, and there are a few extras we'll show. So this is all. There's a little bit of training done on the analyzer, and then the bulk of what we're going to be doing is this hour-and-a-half breakout, and this is fairly loose. Again, the first time we've done this, about exactly how we're going to structure it. I'll give you sort of the overview about how it's going to work. So Lucian and I will have separate breakout sessions. And you're welcome to join the breakout session. What we'll do is we'll each, probably start with a paper, maybe do a few papers, and go through the credibility analyzer, trying to, elicit maybe some conversation, some interaction. You're also more than welcome to go off on your own and fill out the credibility analyzer yourself. And what we'll do is you just create what this is a Google spreadsheet. You just create a new tab of the spreadsheet with some identification of what the model is, and then who you are, just so that we can keep them distinct if multiple people are working on the same paper. Then we'll get back together and discuss what we've got. And I think what we're trying to do is sort of flesh out. We'll pick up on maybe one or so models that have that maybe multiple teams have worked on, and see the different perspectives that came through with the sections of the credibility analyzer, and then some wrap up. And this is also probably a little bit of spillover as well. So that's the way we're structuring this. Before I press on, let me see if there are any questions or thoughts at this point. Again, this is an experiment on our part, but we would really like to get a broader sense of what model credibility means. Okay, and I don't see anything in chat. Okay, all right, let's go on. Let me go through this, the credibility, the COVID modeling section here. And the slide deck, as well as all the resources we're going to use in this section, are under day 4 in the class materials. So, okay. I am not an epidemiological modeler, so all that I know about this space is, like all of you, living through COVID, and then also, reading some papers over the last few days. I imagine, given the size of this group, there are probably a lot of people here who are much more expert than I am, and so I appreciate your inputs and thoughts as we proceed. Um, so with epidemiology, with infectious diseases, you have both a spatial and a time temporal based effect that you want to be aware of as you're doing this modeling. You're trying to predict basically how populations change over time, going from susceptible to disease to infected or exposed to some people are then sick enough so that they require interventions. So those are the kinds of things you're interested in terms of public health demand on the hospitals. Concepts we're all familiar with from our experiences of the last several years. And then this is where the important thing is we're trying to figure out what policies to formulate interventions to address. So there's one of the papers I came across, actually wasn't about COVID, it was about cholera, that I think had some very interesting thoughts in terms of questions you should think about in terms of the model. So so they're talking about, you know, how do we trust the inferences? And this is, I think, somewhat tricky with models for public health, where we're going to use them to guide interventions, because obviously, as we make the interventions, we're hoping that a prediction of a high infected rate or high demand on hospital will change, and we won't have as much infection, and we won't have as much demand on hospital resources. So it's sort of interesting. You could then go back and say, hey, this model was wrong. Well, is it wrong because the prediction was wrong, or is it wrong because our interventions were successful? So I think that's sort of an interesting set of questions. This is about how you might analyze the model or vary the model to in your course of looking at the data. That's something to keep in mind. And then this is an essential one too as we go through these compartment models. I'll give you an example in just a second. Compartment models, so you get a sense of with any model you can add complexity. We see this certainly with the all the work we've been doing lately with the of the course of this class on Talaria models and the number of parameters that might be present. So if you increase parameter complexity, then you get more potentially in the way of predictable capability. But then how do you actually validate that model? So there are a lot of different this is a sort of a summary of this was a review paper in 2023 of different kinds of COVID models that were been developed based on literature review. And so this is a time series model. It's a simple curve fitting. There's some AI/deep learning models. These are the compartment models, the ones that have these notions of the different states, like susceptible and infected and so on. SIR is a common acronym here. And these were by far the most popular, followed very closely by other. So there are a lot of variations on this. And I just give this as more of an eye chart about some of these, in this same paper, there's an analysis of comparison of some of these different models. Okay, so let's talk about the compartment models themselves, and this is sort of the context we'll be looking at. So, so what you're doing with a compartment model is you're classifying individuals relative to the disease that you're analyzing, and you want to develop from the model metrics for how you're doing in your progress with the disease, as well as assessing different interventions. So here's probably the one that you may have seen as an acronym before, and these models, the way I think of them is you start by looking at how do they divide up the population. So here they're dividing up the population into individuals who are susceptible to disease, those who are infected and those who've recovered. Now, they don't have anything here about other outcomes other than recovered. So other models will be more involved and will, some become, don't survive. But in this particular model, that's the way it's been done. So you've got the compartments of the states. That's one part. And then the second part is how you transition from state to state. So so if you go through that, these are the parameters over there. If you take a look at the those transitions between state and state, there basically are so these transition rates, much like with a chemical reaction, we have a combination of parameters and also state variables. So this would be the sort of the density or fraction of folks who are susceptible, infected, and then recover. There's no transition out. So to go from susceptible to infected, you have to have a susceptible person come in contact with an infected person. So that's the SI over here. And then you have to have the transmission rate. That's the beta parameter. And so that's the way in this particular, in the SIR model, that's the way you go from susceptible to infected. And from infected to recovered, well, you've got to have an infected person. And then this is the gamma is the rate at which an infected person then recovers. And so in this model, obviously, over time, everybody's going to end up over here eventually. It's more a matter of gauging at any point in time where, what the infected population is and the needs that they have. Now, something interesting here and how this relates to these models in SBML is that there actually is a direct equivalent between this representation, you probably caught this already, and a chemical reaction. I mean, this is, basically you can think of, we've got different species are going on here. The one thing that you see over here is that you're making this transition, and you can write these in different ways. There's not a unique way to write it, but one way to describe this part of the model over here, going from susceptible to infected, is you have to have a susceptible and infected. If they come into contact, much like if molecules come into contact, then they produce an outcome. Well, the susceptible goes away, and you end up with two infected. Before you had just the one. Now you have two, and to some extent, you could argue that the infected then is a kind of catalyst. And then this is the rate law, which you read off right over there, and similarly over here. So this is the way people will then take these compartment models and translate them into SBML. Okay, so this is, as I mentioned before, a relatively simple model, but they can get to be quite complex. So here's a much more complex model. And so, again, the place you start with is what are these states or compartments? So we see the susceptible, we see infected, we see recovered. So that's the SIR part. But we also have exposed. We have quarantine. This is asymptomatic. So we have much more in the way of states to deal with here. Obviously, more complicated model. I haven't even put down here the parameters and the transition rates, but needless to say, that's more involved as well. The other thing that you see here, which is important from using these models in practice, is how do interventions work? So in this particular case, they're looking at contact tracing. And you can see in the orange what happens when you incorporate contact tracing, that the infected over here, instead of potentially ending up, directly going to recovery or to death, can also, with contact tracing, end up in an increase in the quarantine population, because we look at who is infected and that's going to affect the quarantine. So again, this is then all done by appropriate rate laws. Okay, so many of you are there folks here who have done some work already with looking at COVID models? Let me see, just raise your hands if, again, I qualify this by saying that I am not an epidemiologist, and my contact has really just been reading some papers. And again, my motivation is not to become an expert in the area, just to elucidate what the credibility questions are that are useful and answers to them. So I didn't see any hands. So I guess a sad state of affairs that I become the expert in this discussion. So in any case, it's not about developing good COVID models. It's about asking good questions. So that's the way I'll present it. So the challenges with COVID models and CART models, these are published statements that I just picked up a few of them. They are general challenges by and large. They're not challenges that are unique to COVID. I think they're challenges that are broadly with modeling and certainly with biomedical models. So one of the big questions is, what data are you using for validation and calibration? There are a number of published comments about the nature of the data, about what actually gets reported. How do you indicate that someone actually died from COVID as opposed to another disease? There are attempts to correct this by looking at excess deaths. So there's a lot of complexity with, how reliable the actual data are broadly. And there's some of those, compartments are easier to measure than others, like death. Infection's a challenge one, especially for asymptomatic, because of the amount of testing that goes on. So data is clearly a big issue here. Another thing that I noticed over and over again is you will see cases of models where they did a good job with calibrating the model relative to the data that they had, but it wasn't so clear about how you then map onto this model interventions like sequestering or testing or contact tracing. It ultimately, and saw an example like that previous model where they had the orange lines that show what the effect was of contact tracing. So that becomes a secondary challenge about how you just map on the interventions. And then there's always a question, and these have been very public, about, well, what's the relationship between the model and the actual software you have with it? And then model uncertainty, that's a broad one. Okay. Okay, so let me talk about the tool that we're going to use. And tool here is, there's a bit of air quotes around that. This is really a checklist. And we hope that based on understanding the criteria that we will be able to extend this to actual software tools that can be used as well. And I'll also follow this up by saying, this is something which to us is definitely a work in progress. Part of what we're looking for with this event is to get an opportunity to get feedback on the structure of the tool, or the questions we're asking, as well as the way you answer them. Okay, so we've divided it up into several different sections. So why is it that people, so this is the kind of analysis that you'll be doing. We'll get to the specific spreadsheet and a sort of a training thing, but just to give you sort of an overview of so why did they develop this model? The purpose of a model is sort of central, so we have to have an understanding of that, and that involves, like, who are the stakeholders? Are we talking about government officials? Are we talking about individuals making decisions about, should I travel to location X? So the scope of the model is what all does it predict, and these potentially are very linked. Which the assumptions, is it reproducible? Can do you have data that you can show that it does, either on different simulations or different contexts? And the standard ones, verification to us means that the model is implemented in a way that it's performing what you think it is, and it doesn't do silly things like predict negative rates. And validation is it matches reality, and then uncertainty quantification has to do with variability associated with the predictions and with the parameters. So let me go. That gives you sort of an overview. Here's the actual spreadsheet itself, and if you look in the folder for day 4, you'll still see this particular Google spreadsheet, Credibility Analyzer. This is not something that you can modify directly. We wanted to make sure that there was something there that that you could reference. It wasn't going to change. And then there is a separate spreadsheet that let's see over here. Is my screen visible? Can you see the shared drive? Okay, thank you. All right. So this is the one I was just showing. This is the one that Hackathon Credibility Analyzer that you'll actually be adding tabs to and putting in your analysis. So maybe I'll do this one instead. Okay, so this one you can modify the modifications. That this first page here, what I call template, that's the one that you're going to then make a duplicate of to add in your own information. So what we've done here is for each one of these main topics, purpose, scope, assumptions, we have a number of questions. Yeah, and I'll go through an example. Actually, maybe it makes more sense to just give you an example. So what we're going to do is I'll give you an example of how this is filled in first. So here's a new tab that was added. The way you add a tab is, and this is something you all should be able to do. We should actually verify that you can do this okay, is you go to template, you right click, you press duplicate. Okay, so now there's a new tab over here that says copy of, and then now you rename it. You rename it to something that is going to be unique for you. So if this is, each one of the models has a number from biomodels, so I'll call this model XYZ, and then maybe we've got a big enough group, so you may want to put in your name, something that's identifying you. For me right now, I've just put in JLH. Maybe I'll put in my birthday. Actually, it's coming up. Okay, all right, something like that. Something.
Yeah, I was thinking of adding in maybe a column for like who you are, and then like another tab with like who you are and like contact information or something, name, contact information.
Okay. So, that's a great idea. Yeah. So we could add another tab over here that let's call this. Yeah. Let's see. We'll rename this, and this would be call this contact info.
Sure.
Okay, and then let's say so JLH0824 is Joe Hellerstein. Something like that. And then maybe, put in your email as well, Joseph.Hellerstein at gmail.com. And let's see, I can put in even in a, so let's see, we'll call this your tag. We'll call this name and email.
If we do, if we end up like actually publishing something with this, then that's going to be important.
That's a good point.
Give everyone credit.
Exactly. I do see something in chat. Oh, okay, thank you.
Yeah.
Okay. All right, great. All right, so let me. Okay. Let me go over here. Okay, so here is just an example about the questions. You see these broad categories and like, how do you fill this in? What does this mean? So there are questions to give you some leading indicators, like, summarize the model, who are the users, the kinds of decision supports it provide, that type of thing. And I think the intent is that this is a shared space where you could work with others or you could work by yourself. I think adding rows below, for each, item, question, or thought you have that you want to do, I think that probably works the best. Just add a row below. In this particular case, for purpose, what I typically have been, the way I've been responding to, and again, this is an open area where we're looking for feedback, is since these are all compartment models, I describe the compartments. What compartments it has. This one particular one had asymptomatic, and it also had recovered. It defined those different compartments, and then talked a little bit about the kinds of things that they were trying to do with the model. So okay. Thank you, Lucian. Yep, great. Yes. Okay, so that was Yeah, that's fine. We can do it that way. I was also what I was going to do,
By
but I
tab,
didn't
like
do
the
it.
whole tab is yours or something, but
Yeah. But any case, again,
either
we'll see
way,
what
or
works.
both, yeah.
Either way, exactly. We're just
Sure.
trying to identify to some degree. So let's see. So then scope. So when it is that you thought the model be done, not all these will necessarily be clear. I know with this one, I was a little bit confused. I looked at this paper, and so if you look at the tab, let me bring this up. The tab isn't wide enough, unfortunately. I think I have to go to rename. So, oh, see here. If I, I don't know why I'm having so much problem. Oh, okay. Oh, okay, that's interesting. All right, so I guess the tab had limited space. Okay. All right, so we may want to do to do this your way, Lucian, where the tab is identifies the paper and the contributor. I thought we had more space on the tabs. Doesn't look like we do. And the
The other one
contributor over
did.
here is in the
Like the other huge
yeah.
tab thing.
Yeah, exactly. So I don't understand that exactly. Each all right. So this is the
link to the paper at the top is probably a good idea too, as people.
yeah, right. And then probably at the very top over here we can say, put a link to the paper itself. So the paper over here. Okay, so let's take a look at where the papers are. So if we go back over here to this is the subfolder under day 4. And it says credibility hackathon. So we've got day 4 and the credibility hackathon. So one of the tabs is the COVID papers. And so if you click in there, these are all the papers in PDF format. The number at the top over there is its biomodels number. So you can always find this in BIOS model as well and analyze it in that context. I'll give you a couple of tools that can make that a little bit easier. So the one we were just looking at over here, modeling and forecasting. So if we go over here and
977.
Yeah, 977. Yeah, thank you. So this one here. So you can directly look at the paper. Just double click and go through and analyze it. And so you have access to that. And that's a lot of what I was doing in my analysis is I would go through and I would look at the paper and, they will actually have a lot of the information. Some of the information that I filled out in the in the credibility analyzer in that spreadsheet, what I would do is I would just copy text for the paper. I see a number of things in chat. Let's see what we've got here. Okay, yep. Okay, we still got a discussion going on.
I think.
Okay. So
okay.
Like
the issue is like, is it going to work to actually use Google Sheets? And the answer is, let's try.
Yeah, we'll try.
Done this before. If it doesn't work, okay. But if it does,
yeah,
great.
Right. I think we can do this on separate tabs. That's the way I was thinking of it.
Envisioning it, yeah.
If that fails, if you're having problems with that, just copy the spreadsheet and then work on your own copy of the spreadsheet and then give us a link to it. Could we, what would be nice is in this folder, if I go back over here.
Like, is the folder itself modifiable?
Yeah, exactly. So would it be
yeah.
possible, within the folder itself to be able to so
and just make a new folder? You're on day 3 right there.
Yeah, right. I'm on day 3, so I have to get back to materials. Day 4, I guess I'm in a different tab. Okay, so let's see. I don't know if we could just do something like you could certainly can copy something.
Here, let's try.
Yeah, make a copy. Yeah, so you could do that. Yeah, so yeah, you can definitely.
Right. So the shared folder should be world readable, writable.
Right? Okay, so give that as an option too. like I said, we're still trying to sort out what works best here. It may be easier if you just make your own, make your own copy of the credibility analyzer. Why don't we do that, and then you name it with your identification, like your, whatever your tag is. And maybe what I should do is okay, so we've got this one over here. Should we just have a separate spreadsheet that is with the tag information? Does that make sense? What do you think?
Oh, as opposed to like one. Oh,
well, I said as a one tab.
Yeah, instead of one tab, like have
right,
a one shared thing for your ID.
Right. Okay. Yeah. Okay. So I'm gonna create. It doesn't look like many people have modified that. So I'm gonna create a new spreadsheet and create in this folder, and I'll call it tag information. Tag information. And then we'll call this, we'll have a tag name email. Okay. And so make that a little bit bigger. All right. So I'll be JLH0824. I'll use my UW email this time. Okay. So have at it with that. And let's see, then that should now appear over here. If I do this. Okay, so I got tag information. Great. And I see what we also have over here.
Yeah, I just made, so if you need to make a new folder, a new credibility analyzer and share it.
Yeah,
if you put it in that shared folder, then you can just put it in
that's fine too. Yeah, absolutely. Yeah. That's totally fine as well. Yeah. Okay. And then this is good. So now the only point of conflict really is adding in tag information. All right. So all that works. Okay. All right. Great. Let me go back to the slides. Just have a few more things to finish up. So with the credibility analyzer. All right. Okay. So the activity. So it showed you where the papers are. So we've modified this process. So instead of FS, yeah. So now you probably just create your own spreadsheet. I think that way we won't have the conflict. Feel free to use either. Now, when we were going to do breakouts, that was our initial thought on this, and Lucy and I were going to have separate breakouts to sort of like conduct a broad thing. Let's see how this works. I was going to start in a breakout going through an example of one paper and see if there's dialogue on that, but you're welcome to just do this on your own as well. Let me go through one more thing before we break out and start looking at this. This is the Google Doc about resources available to you. So you'll see this phrase VVUQ, and some of the topics for the credibility analyzer actually are within this scope. So verification, validation, and uncertainty quantification. And these are things that you may want to investigate a little bit to see what these things mean. I know we sort of struggle with them as well. Verification to us is, does the model do what it's supposed to do, and does it not do something silly like negative rates? And validation is correct with the real world, and uncertainty quantification is probably the easiest one to parse. Do you have some measure about variability or other quantifications of uncertainty? We've gone through the overview of the COVID model. There are some data that some of these models come with their own data. There are also data primarily from CDC is the data that I picked up. And it's, like all data, it has some information, but not others. You'll get cases by geography. You may get hospitalizations, you may get death, but, sort of a challenge to figure out the extent to which how much of that data you can use to address especially some of these issues, like, what calibration data do you use? What's your validation? That type of stuff. The last part here, which some of these, I don't know how much of this you've seen already. Okay, so this is just a link to the COVID models. I don't think we've talked about the Antimony web editor. This is a tool that was developed by the SEIR lab. I can just show this. These are all browser-based tool. This is a browser-based tool. It doesn't require any install, and it will provide you with a direct way to get to biomodels. So I think one of the models was 977? Is that right? I think that was one of our models. So modeling, okay, I think, yeah, that's this one, modeling COVID-19. So what this does is, this does a search of biomodels for, in this case, it didn't know necessarily this was a model number, but actually I can just type in COVID. That's an easy way to do it. So it does a search of biomodels, and then it brings up model information. So it basically tells you the title of the paper, and then also where it was published. And then you can click to select it. And now what you've got is you've got that model, that SBML model gets translated into antimony. And now you have the model inside the web browser here, and you can scan it. Unfortunately, right now, there's no way to actually run the model. But what you can do is view the model in detail to see what it actually is. You can get information about the model. So this one here, this is you can see what the compartments are. We've got susceptible to expose. So we've got susceptible, exposed, infected, and recovered. You can get various information about these. I guess I have to reload it again. You get information about the different species. In this case, the species are actually these compartments. And it will actually it has some annotations associated with it too. So that's one tool that is available to you. Let me quickly check the chat. Okay. Oh, okay. Yeah, okay, fine. I think we're up to date on this. All right. So then if I go back over here to the COVID, all right. All right, so that's one tool available to you. Here's another tool that you can use, reproducibility portal. And again, it's a browser-based tool, no install, just run it from your browser. Okay, so what this one will do, I think this works with, it's not just biomodels. There's a broader set of models from this biosimulations project. And we could type in COVID here. And, okay. So this is bringing up some of the model. Yeah, I'm not necessarily sure that these are. This one I think is in biomodels. It should include biomodels as well as others. Now, what this will do is give you a combination in several panes of being able to get to the paper. So you get the abstract of the paper. You can link to the paper if you like. It actually will show you some of the data in the paper, and you can play with the data too, depending on the particular. So this particular one doesn't seem to have data you can play with directly, but then you can also look at the antimony file as well. This is another way of getting to the antimony file. So that's a tool you're welcome to use as well in this analysis. Let me, okay, and then there's the biosimulations. This is a much more complex environment. I don't think I'm going to go through that one right now, just because there's a lot of complexity there. This one here, RAID-SB, I'll go there, but I don't think this is going to be quite as useful for you. What RAID-SB does is it allows you to, if you drag and drop an antimony model, it will tell you, it will analyze the rate laws. So if you're concerned about rate laws being non-standard or potentially inaccurate, the RAID-SB tool potentially is helpful. Okay. Let's see here. Oh, okay. Get a response. Okay, so going back to the slides, that's the activity. And oh, I didn't mean to do that. I went to the, okay. Okay, so let's see where we are right now. Yeah, we're about on time. So so now we're going to transition to the breakout and do the analysis. That's going to be our next step. Let's see a couple more questions. All right, Lucian's handling those. Great. how about, how are we doing in terms of folks understanding what it is that's going to happen next? So, someone popped up with something. Okay, yeah.
It's just me. Yeah.
Okay, gotcha. Okay, great. Okay, so let's see here. Let me bring up one more thing, and that is with the so the cell modeling. Okay, and then we're doing. Okay, do we want which channel are we want to use? Oh, Thursday
I made that
Hackathon.
Thursday hackathon thing. Yeah.
Okay, excellent. Okay, so on the cell modeling summer school, we've got a channel just for the hackathon. And I think what would probably be good I mean, there are general questions you may have, but if you have a question, if you're in the middle of looking at a particular paper and saying, gee, I'm not sure what, if this is really legitimate verification that's going on, yeah, what I would do is type in at least the model number associated with the paper so people know it, or maybe a part of the title. So do that at the beginning and then type in your question. Because I mean, it's sort of a trade-off here, like how fine grained do we break things down? We could break it down by paper. But for right now, we're going to try and just make this a general chat that's available for everyone to share. And I think that,
and in general, this is because like the Slack chat disappears at the end of the meeting, right? So
right, and this way we'll have the record.
And if you don't see it, it's because you're not a member of it. You have to go to the channels button and like find it and join or something. I don't remember how to do that in Slack, but there is a way to do it.
Yeah, I think under channel, right? I mean, it just showed up for me. So
because I added you. If you go to channels, manage, browse channels, manage, browse channels, it'll show you all the ones. You can join them there.
Okay. All right. Okay. Other questions at this point before we try and proceed here. So Lucian, do you know the breakout? Actually, I don't know how to do that.
Yeah, there's a more and then breakout rooms. Let's see if I can.
Okay,
so
let's see here.
Create 2 breakout rooms.
All right, that sounds good.
And should we let participants choose the room?
Yeah, why don't you just choose the rooms, and you can go between them, I guess, can't you?
You can. You should be able to. Okay, I'll try that. Create.
Okay. Yeah, you do it. Oh,
breakout. And there, let's try that. Okay.
Okay, so I see.
All right, so now there are breakout rooms. If you click on the breakout rooms button, does that? I'm not sure like who what you might see as the host versus not the host, but
yeah, exactly. So there are 2
I think
rooms.
you should be able to join a particular room. Let me see. Oh,
so
yeah, people are joining. I will join my own. Oh no, if I join, I will leave this one, I think. But
okay. Yeah. All right. So
there we go.
Okay. So then if I click join, then I will go there.
Right.
All right. Okay.
So are we good to go to do that for now?
I think we're good to go. Okay. I see a bunch of other things in chat, but let's do this before. Okay. 1.5 hours might be a little bit limited. Yeah, it probably is. We probably have some extra time. We can play around with that one. So let's see. Okay. Okay. So you find the breakout rooms. You go to more.
These are in parallel. Oh, and I'm not sure about recording.
Okay. I don't know about recording.
I kind of think the breakout rooms might not be recorded. I think this might just be like us chatting and stuff.
Yeah, which is all the more reason for definitely using, when possible, I guess, using the
Slack
the Slack. Yeah. Okay, and then we'll be recording things as we go, I guess, as in the on the analyzer, the spreadsheets.
Right.
Okay. All right. So, any other questions before we move to breakout rooms? I guess fewer and fewer people are present because they're doing
Or
the
like
breakout room.
anyone who's active has already moved in. So yeah.
All right, exactly. Okay. All right. So,
All right.
let's see. Let's do it by time. So what you want to?
Oh, should we like time for an hour and a half and
Yeah,
reconvene?
right. Right. So
And we can
that would
also.
make it
Oh,
what,
shit.
like 10, 15? Yeah, I'd say go ahead.
No, I'm fine. Go ahead.
Okay, right. What you
10,
want? You
15?
want to do 10, 10, 15?
Sure.
Rejoin? Okay. All right. Sounds good. Make it back. I see Bart. Okay. For those folks in Lucian's room, I apologize if I cut you off mid-sentence. Did we back here together? All right. Lucian, are you present? Bart, were you in Lucian's room?
No, I was not. I was just, I
Okay, all
came
right.
in late.
Okay, that's fine. That's fine.
Yeah.
Anybody here who was in Lucian's breakout? Just want to see if we made it back okay to the main session.
Yep.
Okay, all right. Oh, there's Lucian. Okay, hi. All right, you can unmute Lucian. So did I cut you off mid-sentence? I apologize.
No, it was I got the countdown, so we're still discussing a little bit, but it was an interesting and flawed model, and like flawed models don't seem to have a good like.
Okay.
It was hard to estimate the credibility of something when we found like sort of things that I don't know. Basically, like we felt like they should have been caught in a review of the paper.
Oh,
like
interesting. Did you
right?
do just one? Did you do just one model?
Like at least I don't know what everyone did, but in general, we collectively looked at the model about Iran.
Okay, great. So
yes,
this is awesome. We were able to go through two models, and I know there was at least one person who's going to go off on her own and do some work.
Okay.
How many can we get some discussion here? I just want to get a sense of how many groups, either individual or joint. So we've got Lucian's group, we've got the breakout I was in. How many other people? Maybe some folks did some stuff separately. Can I just go ahead and speak out?
I was working on the 982 paper.
Okay, great, Abby. Okay, so you work on another one. Others? Okay.
I was following along, but I'm not a mathematical modeler yet, so I was just going at a slower pace.
Yeah. That's fine. You go by Kim or Kimberly?
Both.
Both. Okay, so Kim, that's great. So what I think, and is there anybody else? I just trying to sort of allocate time, in my mind mentally, so that we have enough time to go through and discuss what people were able to do in their analysis. Anybody else?
I was going over the 974 model
okay,
with
Jonah.
the Tellurium tools.
Okay, all right, great.
Looks like we were doing 976. So
okay, great. So I don't know how many people have had a chance to do a short break, because we've been at this for a little while. Why don't we reconvene at in 10 minutes, so half past the hour roughly? Sure. And then we can go through a bit of a discussion. Okay, great. See you in 10. Yeah, go ahead.
Anyone who was in my breakout, like put your name on the ID list, like so we can, like, if we do, like, I don't know what we're gonna do with
yeah, whatever follow up.
Definitely like sign up. Like everyone had good contributions, and none of at least I wasn't writing things down at the time, so definitely like put your name things, because I
you could make a tab for it, and then we could add some comments.
Yeah.
Okay. All right, and yeah, same thing. I know some people did in the breakout session I was in, but please, we had that one spreadsheet, and I think there was a tab for contributors. So, okay, see you in 10 minutes.
I'm sorry, Lucian, you mean to put it in the chat?
No, I mean, you can if you want. I can try to copy it in, but there is a
in the tag information.
yeah. Let's see here. In the credibility hackathon is a file called tag. Oh yeah, tag information. Yes.
Because I see only one tag there.
Right
I'm
here.
not sure if
there. No, there's
oh,
two.
okay. Yeah.
There. Go ahead and put your name on that. And someone put it in the chat. I can put them in there also. There. That's the link to the actual document if you want to put your name in it.
Hey, Lucian, I'm curious if there's going to be discussion on where, like suggestions on where to go after this week is over to continue education.
That's
I'd love recommendations, even with, formal programs.
Yeah. Herbert would probably be the best person for that, and he's not here today, but I could certainly, like, I can ask him if we can have all your email addresses. We can like send that information to the list. I know if you're interested in multicellular modeling, there is a workshop. We actually like scheduled this to be the week before that workshop. Oh, Bart, do you have that information?
Yeah, let me just quickly paste in the chat one moment.
So there is so James Glazier, who's been working on it with a program called CompuCell 3D that does multi-cell modeling. It works with Roadrunner. Some like basically like inside the individual cells, you can have a Roadrunner model or an antibody model, basically. And then all the cells interact with each other in a completely different modeling environment system that lets cells grow and move and die and everything else. So if you're interested in that kind of modeling, someone actually mentioned, I remember they were interested in multi-scale modeling. That's one example of doing that. And so
yeah,
when Bart
it's a workshop. It's it's I think it's about 8. It's pretty intense. It's about 8 days.
Oh, wow. Okay.
But anyway, it starts on Sunday.
Sunday.
Yeah.
Not even like during the week. Okay.
Yeah, they don't mess around.
I kind of did this workshop last year. It was great, but we said that we would take invites for this year too, but I haven't seen anything. I didn't know if it's gonna happen again.
Okay.
Lucian, just to let you know, for me at least, the tag information has only viewing privileges. It doesn't let me write it.
Oh no. There. Okay. Now you should be able to edit. That's a good point.
Yep. Thanks.
Oh yeah. Sorry. I missed the comment that was like, it's only in view only mode.
Hey, I have a couple of questions about the reproducibility portal. I think it would have a lot of applicability towards a project that I have a bunch of undergraduates working on. I'm sorry, I'm a graduate student working on my PhD. I have a group of undergrads that I'm primarily working on model merging for a larger pathway model of MCF10A. And I think the reproducibility portal would be great to hand to my team to like say, hey, we want to find a bunch of smaller models like TGF beta, NF kappa B, or like IF and gamma, different signaling pathways. Is it something that you can quickly validate whether or not a model is reproducible or able to merge quickly? It kind of seems like it has a lot of interplay there, but I'm not quite sure.
The idea behind the reproducibility portal is that we have like created these SetML files that like instruct simulators on how to interpret a model, and that has worked on at least 2 simulators and gotten the same results from at least 2 simulators. So getting all the information about like which simulators and how is a little bit still iffy. Like if the on the reproducibility portal, I think in the name it'll have like the name of a simulator there. That's one of the arbitrary simulators that actually produce the results. So the results you see are the results from that simulator. And all you know is that there was another one that also produced those same results.
So does the model have to have a set ML then in order to reproduce it?
Yes, and when we created those set ML things to put them in there, right? And you can creating and using set ML is another whole thing. We could spend a day or two just on that. Tellurium, I will say, just sort of for future reference, there is something called phrased ML that a couple of us put together earlier. That sort of phrased ML is to set ML what antimony is to SBML. Like it's the sort of the user, it's the user readable, like human readable, human writable version of like describing your simulation experiment. That then translates to set ML that then computers can use. Just like antimony is like you defined your model and then it translates to SBML for your simulators to use.
Maybe I'm a little bit hopeful or dreamer, but what would be neat is some kind of interface for, you've probably heard of the tool PETab that was created by, I think, Daniel Windel and the Hassenhauer group.
Yes.
I might have just butchered their names. I've only ever read them.
Right.
It would be great if there was some kind of interface between PETab and setML to just quickly convert the PETab format into a setML. I know that I looked at both tools for some work that I've done, and I just went with PETab for the particular task because you have to find a way to like write the setML, and it just seemed like it was easier to do the PETab format for specification. But I've often thought that some kind of tool that translated the PETab formatting into a setML would be great. Just throwing that out there.
No, it's that is, I agree. I've actually been a setML editor. We did allow, there is a format for parameter estimation in setML that sort of languished for a while, and then because no one knew how to validate, like, is this actually going to work? And then PETab came out and was like, this works, and it works on multiple settings, and we were like, great, we'll sort of use that as justification for like our own format to say. And it's so the setML version of parameter estimation is slightly broader. It covers a few more cases than PETab. PETab has the advantage of existing and working with the actual tools, while setML is much more theoretical. But it's like, hopefully it's getting there, and yeah, translators between the two would be great. So, like if you want to actually, let me think. So the SARA lab is like the main lab in this center for reproducible biomedical modeling. And one of the things, and we got a 5-year grant to do it, and then we just got it renewed for another 5 years. And one of the main things that we're tasked with is to help people do reproducible modeling. And so we have like service projects and collaborative projects and stuff. So if there is something you would like to exist and would like us to write it, if you ask us to, we can justify like charging the center to like work on a translator from PETab to setML or something. So yes, definitely like email Herbert or me or the lab or something and say like, hey, this is a formal request that you do this thing, and then we can say like, great, we'll work with you or do a thing for you to sort of help with that.
It might be worth asking, as long as I'm not holding up the next session or anything, it might be worth asking, just for knowledge in this space, any efforts in whole cell modeling for human cell lines?
The whole cell modeling efforts that I'm familiar with is like the covert model, which is a few years back. And there was a big effort. It was actually like sort of a workshop hackathon that happened several years back at this point to try to translate the covert model into SBML. And like, we weren't able to do the whole thing, but at least a bunch of the pieces were able to be done. The final bit of like having the ODE parts talk to the flux balance parts. Both of those things can separately be done in SBML, but there aren't really good tools that try to do both at once. And like you sort of like simulate for a while and then update your flux balance things, and then those things talk back to each other, right? They coded that by hand in the covert model, which is all MATLAB, I think. But
it sounds a lot like how I work with Dr. Mark Birtwistle, and it sounds kind of like the methods they use or we use, I should say, for stochastic gene switching. Where it's like a 30-second interval of deterministic simulation, and then there's an update period where it inquires on like a stochastic algorithm for gene switching, and then it says, okay, now simulate with that information another 30 seconds and update the update the results.
Yeah, that's exactly the sort of thing where we've been trying to do. So Iran Ragman, I butchered his name and I work with him all the time. Iran, E-R-A-N is what I know him. He works at University of Connecticut. Has been working with a format of a simulation description that's basically a SetML2 version level 2 to try to do exactly that, to try to say like, how do we get these two different systems to talk to each other? So yeah, like an ODE and a stochastic gene switching thing would be exactly the sort of thing where he'd be interested in as well.
Would you happen to know his email? I would love to look into some of that work.
Yes, I will do that. I'll get his email, and Joe, you can take over again.
Okay, all right, very good. So I think we have 5 different reports, and different levels of detail involved. So we have the 2 breakout sessions. I think it's Kim and Jonah and Amy also have some separate discussions. So I think what probably makes sense is let's start with the 2 breakouts, because I think that will sort of set a context. And then hopefully, Kim, Jonah, and Amy can then, you may have divergent thoughts because you weren't influenced by groupthink. So I think that will be good as a contribution as well. As a starting point, let me, okay, so I'll share my screen. Let me go to, get rid of this. And I was challenged here. Okay, so this is our breakout, but I wanted to take a look at what other spreadsheets were, let's see here, which ones do I have here? A couple of those. All right, so let's get rid of. I'm in trouble getting the tabs. All right, so if I get. Okay, now I think I'm finally. Okay, good. All right, so let's see. In terms of, so I see breakout 1. Lucian, did you have one that you were working on as well?
We worked with no tech. We didn't write down a thing. We just talked the entire, like I made a notebook. Oh yeah.
Okay.
Here. So our Iran model testing.ipynb is like the artifact that we created.
And is that in this one here? In the
one down.
Okay.
No.
I'm sorry.
It was in the folder.
Okay. It was in the folder. Oh, I'm sorry.
That thing, right.
Okay.
So I actually made a Python notebook where we were like
made a Python notebook. Okay, fine.
Yeah.
Okay, and so all right, so you did this. This was your artifact, but you don't have notes on the different sections.
We didn't take notes on anything. Sorry.
All right. So what we could do here, if you wouldn't mind too much, let's see. Let's go to this one here, and if we do, like, let's do duplicate, and then we'll call this rename. So this was what?
It's the Iran model. It's
okay.
Model. What number is it? No.
Well, don't worry too much about it. I can find that later.
One of these tabs somewhere.
So what?
976. There we go. Yeah.
Okay, 976. Okay, excellent.
Yes.
So what we can do here is, I'll just put the 976 in front here.
Sure.
Okay. So what we can do here is I'll start with what we did in our breakout session, and sort of in the back of your mind, sort of try and retrace what you did for these various things, and maybe we could just add text as you go through, and the group can help you.
Sure.
So we'll just do it in real time. Okay, so I'll start with thing that we did here. We were breakout session 1, and I'll just do our whole thing here. We did so 9/6. I'm trying to remember. So I guess that one didn't happen. Okay, so I don't know what happened with 970. Oh, did someone start 975? I don't remember what happened with 974, but we definitely have 2 of them here, 960 and 964.
Yeah.
Okay. All right, fine.
I started 974 with just the evaluating the results from the bio models.
Okay, John. So so that was sort of like a space for you to be able to. Okay, so maybe you can even talk to that a little bit, Jonah, as well. If you have some things I don't know if you can contribute to that too when we get done with the other ones, if that makes sense. Okay. All right. So let's start with 960, and some people were better. So Anastasia, you were good about marking your lines, and I actually like your approach here too, just having that as a separate line there. Why don't you on this one, since you've got some markings down, let's see what we've got for 964. Yeah, okay. Okay, so for 960, Anastasia, you want to just give a summary, because I know you were talking quite a bit, and I think you have a good overview of it, rather than just having me talk more.
Sure. Well, this was the second paper that we did, and we chose it because it had some data-driven modeling, because the first one we did was just a purely theoretical model structure. So we thought it would be quite easy to mark it on this credibility mapper, because there are certain expectations in terms of verification and validation when we are dealing with data-driven models. And in general, I think we found that it was quite well, so it was good about establishing assumptions and the model structure, but we weren't that impressed with verification and validation that they've done, neither uncertainty quantification. So even though we were able to reproduce the results, I think it was Jonah that had done that, or it might be someone else. We were able to reproduce the results of the model that they've had. They had done very limited analysis on sensitivity to model parameters, even though they do provide the initial kind of the justification for the initial change of model structure. That was a model of what's it called, MERS, which was data informed. But yeah, they don't do much in terms of sensitivity analysis. They don't discuss the predictability of a model. They don't do anything about uncertainty quantification. And in fact, we have 2 different contributions where it comes to verification, where one of them, the one that's mine, just focuses on the fact that their parameter fitting was well documented. And then I think it was, I'm not sure what the identifier stands for, but another member of our team wasn't too happy with the way that they've they claim they've done the sensitivity analysis. And we did some discussion in terms of the model structure itself not being very credible, because there was no analysis on how sensitive the model output is to different compartments and the different model terms. But we felt like maybe it's not easily mappable to the criteria that are currently on the on this questionnaire. So where does the model structure and model identifiability come in? This was the feedback I think that we had on the questionnaire. So
okay, good. Other comments on this? I know that there was some discussion on some other points, especially the sensitivity analysis. Okay, so one of the things that, the way I think, just sort of this is in real time, how we might go through this, at least for the couple of ones that we did in Breakout 1, is let's go through and just, the summary that Anastasia gave was great. Gives us a thought about these various points that come through. Something that was sort of left out that we didn't see that was well covered by the existing checklist or spreadsheet was the sensitivity analysis. I think that's really the core one that was raised as a point that we don't know in certain parameter regions where certain model parameters may have a greater influence, and that does ultimately affect credibility as you use the model to potentially both interpolate and extrapolate. You want to understand the impact maybe of some parameters might be overly sensitive. So I think that was something that wasn't covered in the spreadsheet. In terms of the model itself, what about, do we have a sense, did we as a group come to a conclusion about how credible we thought the model was? And that's an open question because it takes into account what it was intended for in terms of, being able to help with policy as well as, the specifics, the technical parts of the model itself. Thoughts on this from the group? Yeah, go ahead and just talk, Anastasia. You don't have to raise your hand.
Well, I think we came to a conclusion that it wasn't especially credible, specifically because of this model structure, the treatment of model structure. But it wasn't very clear how do we assess the credibility as a total thing, whether it was measuring up whether the model satisfies its scope that it sets up, or whether it's based on impact that it has on the wider community. So I don't think we came to a conclusion, to a consensus as a group to that, with that respect.
Okay. All right. Other thoughts here in terms of model credibility, or even how to frame an answer to the question, is the model credible? And actually, Anastasia, I like this in terms of there's sort of like two perspectives you gave there on what is it credible. One is it says it's going to do something. Does it do what it say it's going to do? So if it says what it's going to do is predict deaths, but doesn't talk at all about interventions, it just says, I'm going to predict deaths, and it accurately predicts deaths, which we saw, modulo this whole issue about parameter sensitivity. So it looked pretty accurate in terms of predicting deaths and predicting cases. But if it doesn't have a role in terms of policy, the practical impact, can it tell us the effect of, being more aggressive with testing, or more aggressive with quarantine or social distancing? Instead of 6 feet, you have to be 12 feet apart, whatever it is. It doesn't do any of that because that's not within the scope it intends. So, what does credibility mean? And I'm not so much concerned about answering these questions about which one is right, more just like, what are the dimensions of credibility? Okay. Last thoughts on this before we go on to 964. All right, let's go on to 964. So this was actually the first paper we went through. And again, I would like somebody who is this? I apologize. I don't know the acronyms. If you don't feel like stepping forward,
that's
fine.
Open the tab thing, like tab and out.
Okay. Yeah. Well, I want to give people a chance to volunteer rather than volunteering them. Yeah. Do you want to speak to this? Does somebody in the group want to speak to this model as well?
May I do that?
Yeah, please go ahead.
Okay, this model has used the novelty of this model is they have taken human populations and pathogen populations into account, and most of the model is based on mass action. Only the susceptible and the affected individuals are modeled as similar to Michaelis-Menten kinetics. There are two different infected populations, infected symptomatic and asymptomatic. Model is just built in April 2020 just to capture the initial dynamics, and there was no extensive parameter sensitivity predictions or any other things. The drawbacks of this model are there was no mention from where they have taken the parameters, how they have chosen it, and what will be the impact of this. The conclusion is social distancing is necessary. That was the statement which the paper said, but there was no proof of why this is important.
Okay.
Yeah.
Okay, that's a nice summary. And again, in terms of the credibility, first of all, what's your thinking about how to judge the credibility of this model? What you can focus it more. You gave it sort of through your narrative, but you also include a summary. What would be your summary about the credibility of the model? How are you going to judge its credibility?
I don't think there is a credibility. It's just the implementation of the model to show there is some dynamics, but it does not have any specific impact or it is giving any scope of policy implementation. So in terms of credibility, I don't think it has any score to be given us.
Okay, fine. So there's really no way to score it because there's sort of no reality to measure against. So validation, for example, isn't really possible because it's just really modeling dynamics. It's not showing something. It's not comparing with real world data. Is that a fair comparison? Is that a fair summary?
I mean, they claim to have data. They just don't provide it in the paper.
Yeah, I don't remember if they showed us, I don't remember a plot showing predictions versus observations. Was there one in that paper? I don't think there was. They claimed to have real data, but also, I mean, it's a challenge because I think this paper was published early in COVID, so data were limited too. I mean, it's, that's also a fair, restriction on it. But in terms of someone saying, do I have a credible model? Well, given the restrictions you are operating under, you could argue probably not because you don't have real data.
Can
Okay.
I mention that since we're given this paper benefit of a doubt, the other one was also submitted in April 2020.
Yeah, that's
So
very true. Right.
It's around the same
That's
time.
true. Yeah, right. But they did have some data. Yeah, right. That's true. That's true. Okay.
One thing that I'm getting from this is that like these, I was originally thinking of a score as sort of like the sum of these things, but now I'm wondering if they should be multiplied by each other. Like you, especially things that you like have to have. Like if you can't validate something at all, like, and you give that a 0, I feel like that should sort of overwhelm anything else, and maybe the
that's an
credibility
interesting
score should
thought,
also be
right?
a 0, right?
Right. Sort of to make it incorporate it, right?
Yeah, judge everything on a 0 to 1 scale, and then just multiply them all by each other to figure out like what the overall score is. We're going to get some really low scores if we do that, but.
Okay, that's an interesting thought. To incorporate, really, it's to incorporate this notion. There are some things that are just essential, right? If you have no validation, then what could I do with it?
Maybe some things could be added and other things could be multiplied, or I don't know what.
Yeah, so it might be a more complex combination. It's another kind of weighting, really. We're sort of weighting the different elements. Okay. All right. Anything else on? Please go ahead.
So what do you mean by credibility versus the impact? Should we think about the credibility or the impact of the model?
And I think that's a great question, right? How does impact relate to credibility? Is credibility, I mean, that's an interesting question. So in part, credibility becomes important because we're trying to use it in circumstances where there are consequences. So, and that relates to impact, but that's a great question. Like how, it's almost as if we've premised the notion of credibility on the assumption that there is real world impact. And if that model is just sort of an academic exercise, then it's almost like is it really evaluatable on a credibility scale? And I'm posing this as a question. What's your thinking? Do you have more thoughts on this? Because they are distinct ideas in some sense, but I think they overlap, credibility and impact.
I feel like credibility sort of predicts impact. Maybe. Like I don't know, like your traditional impact factor is just how many times you get cited, right? It's like and it basically is some sort of indication of how many times was your data, was your model useful, was your paper useful to someone else.
Yeah.
But credibility, I think, like if you have a highly credible model, you should point people at that and say, like, I bet this is probably going to help you. And then the actual impact is just how many times it gets cited or how many times it gets used. And I mean, number of citations is not a great, or it's not a perfect indicator of impact, but it is the only measure we have that's sort of reliable right now.
Yeah, and for academic, for
purposes,
publication, right? Yeah, absolutely.
But
okay,
at least in the way I think about impact.
Okay. Other thoughts on this point? And feel free just to speak up. Okay. All right. I'll leave it as a question for now. Okay. So I think Jonah, you were the one who said you took a look at 974. You did some separate analysis.
Yeah, I mean, I tried to be as thorough as I could with a short time period. So that means that I didn't get to really look at things like their parameter estimation techniques or even really break down how the equations of an susceptible, exposed, infected, removed model works. I know we talked a little bit about it in 964, which is kind of why I looked at this one, but really the big interest in this one was that they primarily looked at northern Italy at the early stage of the pandemic. And I just remember historically that Italy was swept very quickly with COVID before they implemented a very sharp lockdown measure. And I don't know the exact dates on that off the top of my head, but I just thought that it would be interesting to see how they modeled it in the early stages of the pandemic and if they talked about any accounting for the very sharp contrast and lockdowns that Italy did that were actually rather globally famous from what I remember, because there was a lot of internet pictures about things like dolphins swimming in the marina and stuff like that hadn't been seen in a long time in different parts of Italy. Yeah, I think for what I could do in that time, I enjoyed playing around with Tellurium. It's still new to me, so I quickly imported the SPML using the reproducibility portal. Or I quickly looked at this model using the reproducibility portal. I did notice that I couldn't find it there. I should say that as well. I might need to enter that into the notes. But that could just be me not being able to look that well.
Okay.
So then I quickly pivoted from looking at the reproducibility portal to biomodels just to, pull the SPML, or at least find that number to make sure it matched what I could enter into the Antimony web editor.
Okay.
The Antimony web editor was able to find the SPML, and so I just quickly loaded in there, copied the Antimony script that it prepared, and then pulled that into Tellurium, generated a quick model off of it, and then simulated the results, and it worked well. The results that Tellurium pulled up were accurate to what the publication has as some of the initial stuff, at least the first couple of figures. So I could say that it's certainly reproducible. But yeah, I think that's kind of the extent of what I got out of it.
Okay. So I mean, you did sort of a deep dive on the reproducibility point, it sounds like.
Yeah.
Yeah. Okay. Do you have any thoughts? I mean, I realize you did, the deep dive there, but you also had to look at the model a bit. What about, what do you have any general comments about the credibility of this model beyond reproducibility?
So there are some points that they didn't have experimental data to compare to, and I thought that was great. But I think in my head, I'm also thinking about that shift period that historically came about in their
Right.
and their social distancing and everything that they did in their lockdown period. And I wonder how well that sharp COVID infection period reflected in their experimental data. Like, did they capture any of the post-lockdown deaths or infections or exposures? Because I think that the dichotomy of their experimental data, if not, would be very different from what it would be after a year period, right? So like if they only have data
Right.
from January through February, that might show that the infection and deceased rate is super high, versus if they have it for the whole period of January to December of 2020, might be a little bit more what's the word I'm looking for? I'm always at a loss for words. Normal. You know.
Okay.
Yeah. So that's the only thing I think I would be concerned about. Is if their experimental data did capture that, long time trend.
Okay. All right. So I'm sort of abstracting this a little bit, right? There's certain it's almost a kind of verification. Well, maybe it's a validation, actually. Not sure which one, but you're saying that you have data, in this case, the data pre and post lockdown, that should the effects that are seen, like number of infections, number of deaths, those effects, you would expect those to be reflected in the model itself. It's sort of like a baseline test. Is the model credible? And so you're looking for sort of like natural experiments that then can be replicated by the model. Okay.
Certainly, but this paper was published in May, so the the size of their data set is kind of hindered by time, I guess.
Yes, right.
If that makes sense.
Okay. Okay. All right, great. Thank you. I guess, I don't know if others separately took a look at this model, 974. Any other comments or thoughts on the discussion? And again, they could be high-level thoughts because you don't have to have gone into the details of the paper, because we're really trying to figure out, how to analyze credibility of biomedical models. All right. So Lucian, let me pass it over to you. I'll
sure
stop sharing. And the extent to which, I don't know if anything you can do in terms of adding to the spreadsheet, thoughts, and you've got your team there too. Thoughts from the
yeah, and people have been adding to the spreadsheet.
Okay, awesome.
Thanks.
I haven't even looked. Yeah.
Go team.
Okay, that's even better. Go team. Yes, right, exactly. Go
right.
team. Okay. Good.
Sure. I will share things. So most of what we spent our time doing was reproducing and like running the model and trying to figure out all the different pieces of it. So let me see here. Let's so we found all my Zoom windows make it hard for everything else to work out here.
Yeah, I know. I struggled with that throughout.
Right. Don't. There it is. Okay. Right. So this is the paper. There were a few things we found that were weird, and at least one thing that we found that was like arguably like very wrong. So first of all, we eventually worked out like that there's a lot of equations here, and the SBML version that's in biomodels was created by an EBI curator. So someone had to look at this paper and recreate the paper. So it wasn't the author who had made the model, it was someone else. Like, we don't have access to their MATLAB code or whatever it was. We just have tried to reproduce it somewhere. This is their model matches this data, right? And they have two different versions of it, but basically, like, this is the data. This is just infection rates in Iran from like March to June of 2020. So it was that's how much data they had. They put the model together, and then they say, like, based on this model, this one factor is probably the best way to try to decrease the slope of the second wave, basically.
Okay.
One major, so the biggest problem, well, I don't know. One issue is there's a parameter called alpha that is the number of the proportion of people in the population as a whole who are more susceptible, like with weak immune systems. And they got that from this table, and they just added up these percentages. So they said, like, if you have heart disease, and that's 21% of the population, plus the people with hypertension, you get about 45%-ish of people. So they claim 45% of the population is more susceptible, and that means that's the number of the only deaths in their model, like, come from that population. That's one of their assumptions that I'm pretty sure that is questionable, I guess. Like, you basically, they split their population into two roughly equal halves, and only half of them can die. And the other thing was that their use of alpha, like, is reversed partway through like in some of the equations. So, like, this equation, we're talking about I'll zoom in again.
So is I1 the least susceptible, or the least?
I1 is supposed to be the less susceptible, and I2 is supposed to be more susceptible. But alpha here, which is supposed to correspond to I1, is it says alpha is the percentage of people with a weak immune system.
Okay.
So this definition doesn't square with this equation, but it does square with this equation, where I1 is 1 minus alpha, right? So I don't know, like, in the SVMO model, they went with the curator went with this version.
Okay.
But I don't know if necessarily and that matches their charts and stuff. Like, these red lines match and that's with an alpha that's not the percentage of infected of weak, but the percentage of strong. So it's possible that their conclusion is actually backwards. They say in the abstract that they're, like, we predict like the recovery rate of people without immune system is more effective, right? Of the things that they modeled, they think the recovery rate of people with compromised immune systems is going to be more effective at helping people. But if they got their alpha backwards, then it would that would be wrong. Like, that would be exactly the wrong perspective. So beyond reproducing that particular figure, we would need to reproduce these other charts where they actually make that so, like, these charts change alpha for different things, and then these charts are gamma 1 is the recovery rate of strong immune people, and gamma 2 is the recovery rate of weak immune people.
Right.
In theory, but if they got them backwards, then it's the other way around, right? So anyway, so yeah, there are some issues with this model, and they stem with, so both their assumptions are slightly odd in that they say only those with weak immune systems die, and also I don't know if if their model actually has alpha the way they describe it in the paper, as percentage of people with weak immune systems versus one with strong, because to reproduce this figure, alpha has to be the proportion of people with strong immune systems. So if that's the number they went with elsewhere, then that would be wrong. Right.
So okay. So you've got the
yeah. So the other, go ahead.
No, you go ahead.
And then there's people are chatting in the chat about things as well.
All right, good.
So the other thing is that there's an infection rate tau, and they have a very involved equation for it. Tau is just T0 before lockdown, and after lockdown it's T1. And then during lockdown, it's T0 times x of negative AT. And what A is never said. And why they use T is also very confusing. In the model, like in the SVML model that they used, A is alpha, which is, we eventually concluded is basically nonsensical, and T as time is also nonsensical unless you are claiming that like lockdown is sort of progressing with time. And then we actually like just printed out tau, like, and tau was e to the minus 9, like it starts off at a number and it ends at a different number, and basically those are the numbers that match this slope and this slope. So you have a tau that matches this slope, and you have a different tau that matches this other slope. And in the middle, it uses this complicated thing, which the curator probably got wrong. We decided like it's supposed to be dependent on time over that whole thing, and they didn't do it. So we fixed it, and it made no difference. And the reason is because basically tau goes to several orders of magnitude lower. So the infection rate basically drops to 0. And so you just see everyone recover with no infection at all during their lockdown. You have a very complicated way of saying that the infection rate is 0, and then then you just turn it on again. So I would say that like there's 0 credibility for that particular equation for this like this bit T0 x negative AT. Like there's a variety of ways you can make that equal to 0, and they all produce the same results in their graphs. So I don't know if they just sort of tried that and it worked and they were like great, and they never actually looked at what that meant, or what. But
so I see a couple of things. It's interesting you picked up on this paper. I agree with your comment earlier that a lot of this should have been picked up by reviewers.
Right.
And so but it's sort of interesting. So one issue is the model itself doesn't make sense in terms of the assumptions that are made. It's inconsistent use of, for example, the role of a weak immune system. And secondly is an assumption that doesn't make too much sense, and the assumption being that only those with weak immune systems will die.
Right. Yeah, this is the entire model, which it was nice to be able to see this in Antimoney, right? Like there's like those 2 pages of equations, and it's like, okay, this is what's actually going on.
Yeah.
And you can see recovery for I1, recovery for I2, and death only for I2.
Right.
We didn't have time to see what would happen if we just added a new reaction that was death from I1. In the I1 group. You could even say like mu divided by 2, like just say like this is half the rate or something.
Yeah.
Like, does it still fit the data that they had? And does it still fit the conclusions that they made? We don't know. We weren't able to reproduce we didn't have time to reproduce those other curves. I think it could be done relatively straightforwardly. And if they did, we could figure out if they got alpha backwards or not. Yes. My guess would be that they actually did get alpha backwards, because if you only let your weak immune people die, then death is a way to decrease the infected rate, right? Like After you have one group that can die and like stop infecting people.
And I assume that they're assuming a 0 birth rate, so we're not producing more. Yeah.
Yeah.
That's true.
Yeah, like
there's a.
So if you only let the people with weak immunes die, then I think my guess is that it's the gamma 2 of this function Oh, I don't know. Anyway, so I'm sort of lost now. Anyway, I haven't produced the other ones, but I think it might be backwards. So
okay, fair enough.
Have your
so
hand up. Go ahead.
Yeah, please go ahead. Whoever has their hand up.
Yeah, I'd like to add something more. We mentioned it in the chat. One thing they do that seems a little weird. They want to see how the restriction period affects things, but can we go to the equations?
The paper.
Yeah.
Oh, these. Do you want to go to the paper?
Yeah, to the paper. I think he's asking.
Okay.
So
which
here
equation
in the infection rate, the tau, they put tau 0 before the restriction period, and they put a different tau 1 after the restriction period, which they fit to their data. But that is a different situation. It's like saying that we also add another complexity after the restriction period. We're not having the same thing before and after the restriction period so that we see what the restriction period does. They put a completely different tau 1 after that, and they just fit it to the data.
Right. And
I don't think it makes sense.
We weren't able to read the whole paper. I don't know if they have some sort of justification in that. And you can imagine that people's behavior changed before and after, like in real life, before we knew there was COVID and after we knew there was COVID. But there was nothing in there other than like it fits the data to have different taus. That's true.
But it perplexes things a little bit.
Yeah.
Is the difference due to the change in behavior after the restriction, or is it due to the restriction?
Yeah. Yeah.
If you put a different infection rate.
Yeah, exactly. So, let me look at the credibility thing. So, immune system, a weak submission. Yeah. Are the assumptions clearly stated? No. Like.
Yeah, that's a good one. This is great because very different from the two papers we did in our breakout. It's
okay.
And it's not uncommon. I mean, sadly, things do get through the review process. It probably shouldn't.
Yeah.
So that's good. It's a great case point. So I mean, it's hard for you even to get to some of these discussions of the latter stages of credibility because the first ones, you can't pass. That it's also interesting in terms of scoring. Maybe going back to your thought about the multiplicative scoring.
Right, exactly. Like, would it be a better model if it or is it a better model because it clearly states its purpose? Like, no, it's still like useless.
Right. Exactly. Right. Okay.
Yeah.
So I think like the reproducibility maybe based on their model, we can do that, but for sure it's not a validated model.
Yeah.
It like to me like credibility is like it be verifiable and validatable, and it for sure doesn't have the second one, and the first one also is questionable because they didn't define the parameters very well there and correctly.
Yeah, actually, go back to that because you reminded me of another point when we were looking at the antimony model, and that is that I don't remember seeing units on their parameters.
It may have. I may have like.
Okay, maybe it got.
They have. Oh well, I mean like.
Oh. Well, they have
maybe not like time, substance.
Yeah, right. They have those units, but the parameters themselves, I think, are unitless, or have no units defined. They're not unitless.
Actually,
they have no. Yeah.
Oops, sorry.
Because that's another. Just looking, those are sort of like easy things to grasp in terms of the basics of a model.
Yeah, if you can have your units in here.
Yeah.
I don't see obvious units in all these numbers, so yeah.
Right. And the second thing on this about obvious things, this discussion before about the tau and the tau 1 estimate. What to understand what data were used and then how you evaluate this, that you've got a reasonable estimate. Did you use all the data? Do you have holdouts? How exactly are you validating that you've got a reason? Anyway, so there are a few things there that I think are interesting in terms of, you might call them almost like model hygiene. This is something that, yeah, please go ahead.
Sorry, something just occurred to me that they have these two groups of weak and strong immune system, but they say nothing in the paper how they split the data of infected and fatalities between these two groups. It seems like they've just basically split their data 50% and had 50% weak, 50% with no measurements. And then they've introduced these two categories. So there's no indication that even having two categories helped us understand anything better, which I think is a flaw. If you split your data in half and then make two categories, what have you learned from that?
Yeah,
right. There's also no discussion of and I would have to go to that says the data was taken from this paper. What's the percentage of people with heart disease and hypertension, right? There's adding up all four of these categories.
Oh, that's
assumes that there's no
an
overlap.
interesting thought. Yeah, right.
But if you have a quarter of your population with hypertension, there's going to be overlap with people with heart disease. It might be half the people with hypertension might have heart disease, right? So
yeah, you would expect that hypertension would overlap with heart disease. You would expect that.
Right.
You might argue, maybe less so with cancer, somewhat with diabetes. I'm surprised it's a small number for diabetes.
Iran's
probably
a healthy
not
country as far as that goes.
I was going to say it's not the United States, obviously. Right. It's not the United States. Okay. And maybe the UK does less well, but I don't know.
Yeah.
Okay.
Can I ask a question? So,
yes,
please. About the data. So, for example, I would look at the data which I get from government in Iran with a lot of suspicious, especially about COVID. It was a lot of politics involved as well, right? So, so as a researcher, it's not only about COVID. For example, I get some data from some physicians. They did some study. Okay, these patients had this problem. These patients don't have it, and I start trying to make a model to predict that. But then physicians and the medical society changed their criteria to evaluate if this patient have this issue or doesn't have. For example, the blood clot formation on some type of implant. So, what should someone who is in modeling field do to make sure that what we publish right now won't be not credible in 5 years?
Yeah.
That's a great question. I don't see any way you can sort of future-proof, make it guaranteed to be right in the future, because we always learn more, and we may learn more limitations. So
that was one of the things I first noticed about this data was this big gap right here, right? Clearly something changed that wasn't the number of infected people between these are daily numbers. From one day to the next, this number dropped by 1.2 to from 1.5 to 1.2. That's a change in how you measure cases or something. A whole swath of people that used to be categorized as being infected are now categorized as not being infected, and that's just data collection. That's nothing to do with anything else. We have a couple
or definition.
Yeah, definitions and stuff.
Right.
Yeah.
But at least about the data infections and stuff like this, there's common sense that you can employ. So we did it with master students in 2020. We tried to build simple predictive models and tried to use our olden data and stuff. And Iran famously or infamously was reporting linear increase in cases in March 2020. So we know that it's exponential. That's just the common knowledge about growth model.
Right.
Yeah. So we didn't
unless they were doing it in log units.
So this was kind of an interesting exercise, but sometimes you can just have a look. And then it was quite lucky that we had such abundance of data, right? Every country was reporting. So you could easily pick out something different. But I think if the data is limited, then there are no easy ways to check, or if there's no first principles known about some phenomena, then it may be difficult to check.
Absolutely. Right. And then, data is sort of foundational here, both in terms of, being able to, what inferences you can draw, and also the basics of model calibration and then model validation. So if your data are bad or suspicious, that's terrible. Yeah, it's really problematic. Okay.
We have another hand up. If you want.
Yeah.
Yeah. Can I add something more?
Yeah.
Yeah. Another thing that bothers me a lot is that that goes firstly to the credibility and the impact of the paper itself, and goes down with the modeling after that. They are putting a restriction period, which usually when you talk about diseases is reducing how much people interact with each other. Mostly that is the control mechanism. But what they are talking about is putting a restriction period and then saying that what affects things is that we are showing that what affects things is if we increase the recovery rate of the weak immune individuals, we are getting better results. And that is something, I think that is something too complex to control. How can you say that we increase massively the recovery rate of all weak immune individuals, and what does that have to do with the restriction period? Do we provide better healthcare for all of them and it works amazingly for everyone, and that is just for a restriction period that where we provide better healthcare for them? It doesn't make sense for me. I'm not sure.
Yeah.
Okay. Other thoughts?
Putting any of these thoughts, throw all these thoughts into the spreadsheet. If you
Yeah,
can.
anything you can. You're right, because we will have the recording, but it's going to be so much easier for us if you can, the extent to which you can synthesize something into a written statement, no matter how short. That will help a lot. Okay. Other thoughts on this model, 976. All right. So I think we had a couple of others that were individual. I remember Kim had one. I don't know if you Kim.
No, I did not have an individual. I was just doing it on my own because I'm not a data modeler yet.
No, actually that's fine. And you can just is there something, Kim, maybe you can say, maybe I misunderstood. I thought you had done something in the way of another model that you had looked at, and the fact that you're not a data modeler yet is fine, actually, because we want to get a range of viewpoints, and to some degree you're potentially not influenced by the groupthink of those of us who've spent maybe too much time doing this already. So we welcome your thoughts.
No, I was just commenting on doing something independent simply just because my pace was a bit slower. So I wanted to be able to fumble on my own, but no.
Okay, that's fine. That's fine. I'm not. Yeah, all I'm trying to do, Kim, is if you felt comfortable, if you had any insights, no matter how seemingly modest in your mind, we would appreciate it, because it may be something that questions assumptions that we shouldn't be making.
I think what I had seen was already mentioned on the 960 paper. It was about just the 6 countries where data was being collected. Not all countries were in the same phase of infection rates.
Okay, good. So the data issue, right?
Yeah, data issue.
Okay, that sounds great. All right, good. And I remember Abby had something that she was potentially working on separately.
Yeah, that's right. Do you want me to share my screen?
Yes, please do, Abby.
Okay. Give me a second.
No problem.
Okay, can you see that?
Yes, right.
I just have the
Tracking the
paper up.
early depletion.
Yep.
Yeah, right. Yep, we see it.
Okay. Yeah, so I worked on this paper, which tracks the early depleting transmission dynamics of COVID with a time varying SIR model. So these authors modified the basic SIR model by implementing a partial time varying infection force. And this is meant to model the initial reduction in infection cases when lockdown measures are put into place.
Okay.
And so apparently, yeah, here's the SIR model, and this is the rate that they modified here. Apparently, the effective reproduction number of COVID cases decreases over time. Where is that? Yeah,
Okay.
over due to initial lockdowns, and this reduction, they captured that reduction in this power decay log in the rate log. So that was the only modification they made. It was pretty simple.
Okay.
Thankfully. So the authors fit this model to reported infection data from Malaysia after an initial 12-week lockdown that was initiated on March 18th. And they reported that they were able to accurately model the initial reduced number of infections better than the SIR model. But with that said, this model is probably only effective for modeling infectious disease in places where there are early lockdowns put in place. And they said as much. I thought their assumptions were clearly stated, and they made sense. Like I said, the model was simple, so a lot of their assumptions were based on like pretty standard SIR assumptions. Including like the entire population is equally susceptible during an infection period.
Okay.
Unfortunately, I was having some trouble with getting my Python script to work. I'm also not a modeler, I guess. I have a bioengineering background, less computational. So I didn't get super far in like the reproducibility verification validation sections. I'd be happy to continue working on that because I did get it to work.
Well, that would be super, Abby. And
yeah.
Actually, by any chance did you make us a spreadsheet too?
Yeah, it should be in the shared folder.
I didn't look. I should look. Yeah, let me go.
Yeah. Do you want me to share that instead?
No. Well, yes, in just a second. What you're doing right now is excellent.
Okay.
Let's see here. What I don't see. Did you upload it? Is it in that credibility hackathon folder? I don't.
Oh no, I put it in the shared folder for everyone.
I see
the
it.
subfolder there.
Yeah, the subfolder
that's
there.
the one people could actually edit and put new documents in.
Gotcha.
Right?
Yes, of course. Okay. All right.
Mm-hmm.
All right. So so I see it's a AA 982.
That's right.
Okay, great, excellent. Yes, why don't you, did you, that's a nice summary of what you said so far about the paper.
Mm-hmm.
Anything more on that before you switch gears and look at the spreadsheet?
Oh, I was sort of building off of the spreadsheet as I went. So I kind of went over SIR, like those are the compartments.
Right.
I guess not. We can move to the spreadsheet.
Okay, all right. All right. All right. So you modified the template tab. That's great. That's fine.
That's right.
Okay. Let me just sort of glance through this.
Yeah, like I said, I didn't get super far with the reproducibility sections. But like one limitation that I did identify, and I'm curious to hear what you guys think, is that they had a very limited number of data points that they used to develop their model. They fit their model to reported infection data with only 42 points. And this seems pretty small to me to create a generalizable model. And the authors admit this in their limitations as well. And of course, like that lack of data makes a lot of sense because scientists want to make predictive models like this as soon as possible to like inform the public of like continued developments in COVID spread or other disease spread. And in fact, this model was apparently, according to these authors, used by the Ministry of Health in Malaysia to periodically assess whether they should continue their lockdown procedure. So it makes sense that they wanted to get this out really soon. But I'm curious to know if this like number of data points is common to develop like similar biomedical models.
I would say it's varied, like some, but often you have a paucity of data. You just don't, there's only so much you can collect, and so you really try to do what you can with it. But
sure,
I would say overfitting is definitely a problem in the field of modeling, because if you have a model with enough parameters, and it will fit the data, especially if you only have a few data points, and if they're all supposed to be in a line anyway. Yeah, so it's
I think you also raise, at least indirectly, another very interesting point about model credibility. So if models are being used as part of policy formation, and you have some events like a pandemic where initially you recognize that there's something that requires intervention, but you have limited data, then okay, I'm at the beginning of this event. I need to make policy decisions. I would like to have a model to do this, but my model is going to be limited based on the data that I actually have in hand. Is that model credible? I mean, that's sort of the question. Yeah, go ahead.
I think it's maybe not inherently credible, but I think if so long as the authors make good effort to validate it appropriately, then yeah, I think it's totally possible for it to be credible.
So here's another thought. As you were talking, and I was thinking about the question I asked, I'm sort of thinking that maybe I asked the wrong question. It's not so much whether or not it's credible. It's maybe a matter, is the model usable for decision making? So we're sort of inferring credibility as an absolute from that, but I have to ask the question, can I make decisions about, gee, I need to go into lockdown. I need to limit, do more extensive social distancing. Do I have a model that's good enough to make the policy decisions? And then based on the fact that, what risks am I trading? I'm trading potentially tremendous inconvenience and social impact on society versus death. Right. Those are the trade-offs I have. Yeah. Right.
Yeah,
so
I was going to say, I wonder if that's more of like a risk, a cost benefit.
Yeah, a risk assessment. Yeah. But yeah. maybe the question about the model is, can the model be used to make these judgments, understanding that there's going to be a lot of uncertainty, and then I have to deal with these competing, outcomes, the risks associated with the decisions. So I asked that more as a post, because we're still trying to get, ultimately, I mean, at the start of this whole, hackathon, it was, we wanted to understand more about model credibility. I'm almost wondering if, maybe there is a little bit of a reframing about what we mean by credibility. It's not an absolute time invariant, kind of statement. It's more like, can I use this for an intended purpose? And that may be a point in time purpose. Yeah.
That's sort of the scope, right? Like, where and when should the model be used?
Yeah. Maybe. Okay, fair enough.
Yeah, like can I use it this month, or like to make a policy decision about this particular thing, right? What's the scope of, and if I, and yeah, and then coming back to it 4 years later, like, is it still useful in a new context or not? Or
well, that's fair enough. So when we talk about credibility, we talk about credibility for a purpose.
Right.
Right. Not the best model if I want to get absolute predictions after the fact with all the data, but for a point in time where there's a very impactful event unfolding, yeah, it may be credible for that because that's all I've got.
Right.
Yeah. Okay.
Yeah, I agree with that.
Okay.
Also, what about previous outbreaks, like Ebola outbreaks or other models that have been performed historically, could there be any influence on prior modeling efforts on a different infectious disease host pathogen?
Absolutely. I think one of the papers that I referenced in the intro was a paper about actually a cholera outbreak. And so absolutely, you would think that other infectious diseases, obviously some of the detailed characteristics are different, but many of these models are very general models. It's more a matter of how you tune the parameters.
I mean, like, because the SIR model is a standard way of doing things, then we know at least people in the field should have a good idea of like when an SIR model is appropriate and when it isn't.
Yeah,
because we've used it so many times in so many different contexts.
Right. Anastasia, you got your hand up?
Yeah.
Yeah, I just wanted to, I think, highlight that in a pandemic situation or any epidemic, you're not operating with a single model. Yeah. So, for example, here in the UK, there had been nationwide a number of teams that already had pre-established models trained on SARS and MERS. And so what the government, it was an interesting structure, but essentially they were asked to reproduce a number of metrics, such as R0, potential number of deaths and stuff like that. And then this teams met every week to come up with a consensus of their results. So you have a sort of credibility by multiple people doing independent work, trying to answer the same question. So if you have a decision where the output that's way off, then that's your outlier. And that model then is not able to reproduce the results, so that drops off naturally. So, I mean, it's not that UK did very well, so we're going for a period of inquiry right now, but the modeling work seemed to have been streamlined well enough.
Right. Okay. I just wanted to take a note of that. That's the interesting part about the credibility, the credibility process, that with multiple models and competing groups, that there's, to some degree, it's like a peer review process. You can do comparisons and gain more credibility from the fact that one or more models has sort of, stood up against scrutiny. Oh, okay.
The politicians still can misinterpret those results, though, and sort of go.
Yeah, that's a whole other challenge, isn't it? Yeah, exactly. Right. Yeah, there's only so much you can do on that part. We as more on the science side, deal with the limitations of what our roles are. Okay. Other thoughts at this point about, what Kimberly described, what Kim described? Or I'm sorry, what Abby was discussing? I apologize. What Abby was discussing? Okay, so let me, let's take a step back. Oh, okay, Amy, go ahead.
I can stop sharing. Oh, sorry.
Oh yeah, I just had one thought in that, I think what Abby said was, like, they compared the SIR model to the model with the extra parameter, including the, the effect of lockdown, and then said this fits the data better. So I was wondering, did they do, as I think Lucian mentioned, like, including extra parameters means you obviously fit better. So did they do any analysis of, since if that was their main goal, was to compare two models, did they account for the number of parameters in their analysis at all? That was all.
I don't know if you, Abby.
Yeah, that's a really good point. I like it.
Yeah, I'm not totally sure. I would need to continue kind of delving into that section of the paper, which I am interested in doing.
Yeah, absolutely. That would be awesome, Abby, if you could, do, a little bit more with that. I mean, actually, this discussion, like I said, this is the first time we've done this. It's sort of an exploration, but I think part of it also brings up the thought that there may be value to sort of doing the credibility analysis in two steps, One is we go off and we get an initial in-depth thought about the papers. We have a conversation because I think that will help orient ourselves. And then we go the next step, maybe a little bit more focused. So that may be a thought for future events.
I mean, that's basically what we did, right? We just talked about the paper forever and like messed with it, and then when we back in this setting, then with everyone else.
And in this setting, that's exactly right. That's what we did. Yeah, exactly right. Okay. So, any other thoughts about any of the papers that we discussed, or some of the concepts, like we're trying to dig deeper into what is credibility? I didn't know if someone has some other things that have been percolating in the back of their brains. Okay, go ahead, please.
It's more about can the credibility be broken into different parts, like credibility of a model, impact on the field, impact on the policy, as different parameters, and make it as a rather than having it as a whole credibility kind of a thing. Can that be modeled in like how we have verification, validation, and extensibility of a model as three different things?
Okay.
In that way, credibility also has like credibility in terms of modeling, credibility in terms of extending the model, and credibility towards impact on the society or on the field. That might be a better way to approach.
Just right. I'm sorry, I missed the second one. You got so credibility in terms of modeling. What was the second thing you said? The last one was impact. That was the second.
Extensibility of the model. Can that model be
extensibility? Okay, great. Thank you. Any other last thoughts? Okay, so the last thing I'd like to do is sort of get your feedback on this, how we ran this event, because this in and of itself is sort of interesting. This notion of a hackathon being remote. I mean, hackathons a lot of times, the hack part supposedly involves coding. Some of you actually did some coding, but I think a lot of us were just more looking at papers and sort of having a discussion, writing stuff down. So any feedback about what might make this more effective, more more enjoyable, promote communication better? Any thoughts on those points?
Well, I can certainly. Oh, sorry, you had your hand up.
No, go on. I'll go with it.
Okay, thanks. Not necessarily a comment on anything that could be done better, but certainly an appreciation to this. I've already shared a lot of these resources with my team that I'm working with. I think that having the ability to look over a multitude of different papers with you guys, kind of hand holding us along with the first one, and then quickly taking another one myself and trying to get the bio model with the different tools you guys have presented, the SBML file, try to look over it real quick and assess the credibility, really provided a nice intuition, I think, that I can carry forward. So I just wanted to express some appreciation for that.
Good. Glad you enjoyed it, Jonah. Yeah, please go ahead. We've got a few. So let's see. I guess Lampros. I'm sorry if Lampros Marius. I apologize, but
yeah, it's good. It's good. Lampros.
Okay. All right. Great.
Yeah. Good. I think it's great. I would suggest perhaps an intermediate step before the credibility assessment, where we could have, for example, a hackathon that included us modeling, doing some models in antimony and in tellurium based on some papers, and then assessing both others' models and our own. So we could see where we went wrong and lost perhaps the credibility and the extensibility and all the parameters. So we could evaluate how we went about it as a workflow.
Gotcha. That's an interesting thought. Okay. All right, go ahead. I think Kim, I think you're next.
Kim was next, yeah.
Just a quick analogy. I don't know if anybody this is random, but anybody has ever done live nude drawing. The format is 1 minute, 2 minute, 5 minute, 10 minute, 20 minute, and then 1 40-minute drawing. And whenever there's a, a big white page on the, in front of you, and you've got to draw something that looks kind of complex, I really like the process of forcing something on paper in a minute, and then 2 minutes, and then 5 minutes. And so it's an exercise to force you to get form without trying to go too detailed. So if there could be a way to use that kind of thinking, I liked our format, but I found in the beginning is that with 15 people in a room, there was only a few people engaged. And I think I was trying to get used to what the process would be in general. And so maybe if there could be quick vignettes to get the process going faster, step by step. Like it's nice to have 5 papers reviewed overall, and the one big breakout group that only got 1 paper, maybe that analysis was, I wonder how, an iterative process could have helped.
Okay. So the iterative process, and I'm not familiar with live view drawing. I guess I'll just look online for that. But this idea of, a progression of interaction lengths to then sort of do resets that you can then figure out, am I doing the right thing? Right. Gotcha. That's an interesting idea, Kim. Okay. All right. So who's next? So please, go ahead. I think we have one hand raised, so that's great.
It's kind of a suggestion kind of a thing. What we did is like a tutorial of how to do this credibility analysis. If the same thing has been like we do by ourselves, taking 2 or 3 papers, and we do the credibility analysis by ourselves and upload them or submit as a Google form, and next day we review, like, if we are dealing with this, what are the opinions of people who have got trained in attending the workshop and getting trained in this? What are the opinions, and how is this kind of assessment of the paper or the model? This might be helpful, and it might be more like getting the consensus out of people, like giving a space for them to implement on the same thing and then work on, have a discussion. That might be a bit helpful. It will be helpful in teaching as well.
Okay, that's an interesting thought. I mean, actually, it's what we're going on a premise, which may have been a false premise, which was that we really needed to. We couldn't count on people doing work in advance. We thought that we had to engage people, directly, and the work would happen in a group. But it'd be an interesting experiment to try. I think you're absolutely right. With more thought and being able to work a bit independently with the proper sort of setup, because so like what Kim was talking about with this, these short interactions to sort of get people oriented right. That could be very effective if we could get enough people willing to commit that they would read something in advance and submit a form. So that's another interesting thought.
Either individually or on groups, but have a training on that, give some time to them for themselves to work on, and then we can have a discussion kind of thing.
Right. But definitely would be more thoughtful if we could make our way through that. That sounds good. Okay. Other comments or thoughts here? I mean, we actually are running right up to 4 hours. So you all have committed quite a bit of time, which I really appreciate. Both do. I'm also impressed with how many people are still connected. So I think we started with 35 and we're down to 33. So that's also very impressive. That says something. So, okay, well, great. I think this, Lucian, I don't know if you have some final words.
No, I think, it was, I was leading it, but I didn't really know what I was going to be doing, but it worked out. And I really appreciate everyone in my group who chatted about things and was really engaged. So thank you all.
Yes, right. I second that as well. Okay. All right. Okay. Well, with that, I hope you all enjoyed it. And I guess there's one more day too, where we have some individual presentations tomorrow for the full week. So, okay, great. Well, thank you very much.
Thanks, everyone.
Take care.
See you tomorrow.
All right, bye.